Hi and welcome back to the third part of this tutorial. So in the previous video we talked a little bit about adding radiators, and as you can see I have changed the text a little bit here. So instead of manually inserting radiators into each room, we're going to actually just add room units. So if you go to General tab and we take room units, you should have ideal heaters in each room. And if you do not have that, you have to make sure to check each room individually to see that you have ideal heat room. If you have ideal heater, I mean, if you have ideal coolers, these should be removed. So you can start deleting ideal coolers in all the rooms. I already have deleted most of the rooms. I mean, ideal coolers for most of the rooms, and these ones are the ones that are left. And also, as you can see here, some of these rooms should not have any heater. For example, the garage should not have heater, and also the sauna should not have heat. Let's see where it is. Okay, I already have removed it for the sauna. I can double check here. I don't have any room units. Okay. Okay, let's see here. So what we need to do is we need to add 1000 watt max. So if you go back to general and we have room units, we have actually it's 10,000 watt. And you can see here I already have configured. If you do not have 10,000, you might maybe have 1,000. You should change all of this to 10,000. And also, okay, I'm just checking the energy meters on this one. Should be okay, they are correct. Okay, the next one is the occupant. You should remove all the occupants from all the room except kitchen, family, and master room. So if I check internal gain, I already have removed all of the other rooms. So I only have kitchen, study room, laundry, and family room. So in your case, you have to actually delete if you have occupant in the other rooms. And that one is a standard. So you just okay, there's one thing you should actually do. One in kitchen, one in family, master bedroom. Then okay, so what you need is the number of units. You need to change this to 1 actually for each of this room. So, and then we have warm water consumption. This can be found in extra energy, domestic hot water use. Average should be 20, which I already fixed. And the unit should be kilowatt hour per square meter and floor area and year, which I already have chosen here. Okay. And we can check out how our model looks like. Okay. I see something here. This white wall should be facing this side. Let's see how it looks like. Let's see where it is actually. This is the garage. Okay, so it's the master bedroom. So this wall should actually be facing, let's see here, it should be facing F2. So I can change that. This side should be facing F2. Okay, let's see, this one is already correct, yes. Okay, so I can close this one down, go to 3D. Now that one is fixed. The next part is actually we need to create, let's see here. So the next part we need to fix the garret, which is this this area just directly under the roof that we have. So we need to create a second level basically. So go back to the floor plan and let's see here. So we need to create a new level. So I can choose here a new level of 2.8. Click OK, and then we can create one single zone here. You can just mark the outside, I think. Yes, so if you go outside here, then it will auto fit to your exterior boundary. Click OK here. So let's see. It's also a good idea to click to roof here. So that one should fit the size of your exterior roof setting. And you can check actually the lower level. Click OK. So we can switch between these two levels with show floor plan at level. Click OK. So here we can see the porches. From one we have on this side, one we have on this side. Then we have the entrance, and then we have some small garden here. And we can also change, actually, if we go to the floor plan and let's see here. So what we want to do is to fix the height of the rooms. So in this case, we have 2.6 to ceiling, and we should change this to 2.8 on all the rooms. So change this to 2.8. I think we can actually go inside the zone here, and we can change all of them. Okay, let's see here. Copy, paste. If I click copy here. Okay, now I can paste it. We're gonna change everything except this one, zone 1 here. This is actually the, I'm gonna rename this one to the garret. So I'm going to change this one here, and then change them like this. And for the last one, we won't change because that will anyway auto fit. We need to change the ventilation. We won't have any ventilation here. Just put 0 here. double click on that. Sorry, control the set point. This one actually, you can just leave it like it is, because you have to remove all of this. So we won't have any ventilation and we don't have any units. So there is nothing in our simulation that it can use to try and get these settings. So it really doesn't matter what you set here. So let's just ignore that one. Make sure you have two roof at least here. And if I check floor plan, this one should be to ceilings. As you can see here, this is correct. And then if you go to level 2.8, this one should be to roof, which is correct. And then we should be almost done here. There are some things that we still need to fix. As you can see, I have some gaps here that I want to fix. So I can go back to floor plan, go to level 0, click OK, and here I need to start to, for example, here, if I press edit, need to move this one a bit closer. It's very far away. Done. Move this one closer. Need to check. Let's see here. Okay. These ones are a bit too far actually. Let's edit them. Edit. And edit. Okay, let's see here. This is actually pretty far away. Need to move this one a bit closer. Okay. Actually, edit this one a bit closer here. Okay, now we can actually try and make a test simulation run just quickly to see if everything is working as intended. Here, for example, as I told you, we have some gaps here which I don't like. Let's see if we can fix this. It should be over here. Edit. Done. Here is another one. Edit. Done. Edit. Done. Okay, let's try again and see how it looks. Okay, this is pretty decent actually. Okay, on this side you have maybe need a little bit better the front side. Let's see here. You can also actually zoom in case you don't see. So we have actually view zoom in case, okay, you cannot see. You can see you can actually zoom in in case you want to do that. View zoom out. So if there are any specific areas, you can actually zoom in and configure, as you can see, and so on. And zoom out. Okay, let's try a simulation anyway. So we go to simulation and we check setup here. I'm just going to do for a short period of time for now. So we have 1st of January to 31st. Click run. Let's see if I get some errors here. As you can see, I did not get any errors. Let's try an example where I will get an error. And let's see. So in case, for example, let's see here. If I change this one, so edit, and I draw this line, so it will actually, let's say, cancel here. Edit. Okay, so it does know actually. So let's try. Let's try this one actually. Edit. So as you can see, now I overlap this zone here. Done. Now we can check what actually happens if I try to simulate this one. As you can see, intersecting zone, living and whole. So as you can see, I got actually some kind of error here. So I need to stop this, abort, and I need to fix this one before I do my simulation. So I need to go here and I need to click edit and I need to change it back to what it was before. Done. Okay, so I can use clear messages and do a simulation again. And let's see if I get the same error. Nope, I did not get any errors. Okay, let's stop here, abort. Okay, so let's run a simulation here, see that everything is working. I will let this be on, and I have set only for January month, so it goes pretty fast, and then I will have the result. Okay, so I know now that it is actually working, which is good. So this is pretty much it. So for the next part, let's see here what we have. So what I need to do is basically I need to perform a simulation of the house to find out how much is the heating demand during 1 year. Okay, so this we can do by checking the simulation setup, and you can choose just 2017 until December, end of the December 2017. That's 1 year. Save, that one. Let's see here, did it say? Okay, it's saved, close. And if we read further, which room has the highest heating rate in total per square meter? Which part of the building has the highest energy loss? Save a copy of this building as a base model, and so on. Let's see here. Okay. Further down, you see that we have to have also we have to check the Funger's comfort index. So we need to think about that, and we need to actually change some of these settings here. Let's see if I can find it. Let's see here. Okay, you can actually find it over here at this button, list of output objects. So here are the things that we might be interested in. You can actually click diagram zone level heat balance. You can have Funger's comfort indices. We can also have, let's see here, energy, liquid energy. This should be actually enough. So this is the thing that you need to remember. And oh, actually we have a thermal comfort without cooling. Let's try this one as well. We can have this one as well, also doesn't matter. So try to add this in the list of output objects before you do any simulation. Then we can click OK here. And this is pretty much it. I think we have done all the settings that we need. Let's see here if I have anything I need to change. Let's see here. Okay, this looks good. So what we need to do next is actually start the simulation of our house. So click setup, make sure that you have 1 year dynamic, and then run. And I will be back when the simulation is finished. Okay, so now I have finished the simulation, as you can see here. So if we check what our task is, we have to perform a simulation of the house for how much heating, how much is the heating demand in 1 year, which we already have done. Which room has the highest heating rate demand in total per square meter? So we can check several ways. Let's see here. We can check if you click on multi-zone here. There are actually several ways. We also have here maximum heat supplied. Maximum heat supplied by air and room units. And here we can see that bathroom 1 has actually the highest maximum heat supplied. So the answer to this question is basically, you can easily extract it from here. Which part of the building has the highest energy loss? And by the way, here we can see the total energy that's needed for this house or that's used, and that is pretty high number actually. Anyway, so we can go to, let's see, go back to the question is which part of the building has the highest energy loss? And we can click multi-zone, click all zone, and click OK here. So this is a comprehensive list of all the zones, basically the entire building. So to answer this question, which part of the building has the highest energy loss? We can see here that the envelope and thermal bridges is actually the highest negative post. So this is where we have the highest energy loss. And that's about 86,000. And the second highest is the infiltration opening, which lands at 22,000. And as we can see here, we can also have a split here. This part, envelope and thermal bridges, is divided into subsections here. So we can see, okay, which part of the building specifically has the highest loss. And here we can see actually the walls has the highest loss, which lands at minus around 42,400 in total kilowatt hours. Okay, next question. Okay, so what we need to do here, save a copy of this building as base model. Okay, so what we need to do is let's see here, save as we can say that we want to call this base model, base model, click save. Okay, perform an energy analysis. An example, change the indoor temperature, thermal bridges, insulation. And how do we do that? So what basically what you need to do is you need to let's see here. There's one thing you should also know actually. I never finished building up the model actually. As you can see, we're still missing doors and windows. So actually I will go ahead and I will do those things as well. I will not go through everything, but I will actually show you how to add windows and the doors. Just I'm going to show, let's see here. Okay, so if you go to the floor plan, you see here, for example, here should be a door, external, here are the windows. I'm wondering if we had, yeah, we have actually what the windows should be. Let's see here. Here we have the windows, 2-pane glazing clear. So how do I add windows? You can right click. Actually, it's better if you double click And then need to see the orientation. Okay, so we have two external sides here. So this means it's one to the north and one to the west side. And to the north, we should have an external door, and to the west, we should have a window. So let's do the windows part. So double click on that, new object, and then choose window. And then because we put the default at two plane glazing, so that's already done. And then how to configure this window. Try to have a height of in y direction at 1.2 meters. Actually, I was a little bit high, so let's go with 1.1 meter. Should be okay. And the size should be 1.2 meter and 1.5 for the X and Y. But then we can actually change the width of the window in this mode. I will show you that in a moment. So now the window is done. The most important setting is actually this one. It should be 1.1 above the ground floor. Okay, so here's how it looks. And here is the good thing. We can actually see the window here. I just moved this one so you can see this is the blue line here. So let's do an undo. So what I want to do is I need to move this window so that it will fit the windows that we have here. So let's lock down the zones, and now I can actually mark this window over here, and I can move it up and down, as you can see. Try to move it so it will fit the drawing behind them. So, and then basically, because we have the same height and size of the windows, at least most of them, you can just copy and paste. So we right click on that window we have created. Let's see here if I can manage to do that. And then copy, and then we can paste it. Paste on that place and paste here. And then paste here. Paste here. Okay, pasting here. Let's see here. You notice some of the places that the window is smaller than the drawing, so we need to change the window. We can do that by checking the geometry, and in the X direction should have it larger, 1.5 for example. And then you can go back here and see, okay, this was better actually. And I will delete that one. I'll delete that one. I copy this larger window here. Then okay, let's see here. We have actually two windows. It's actually too large for that, so I need a smaller window. I'm going to choose this one, copy, paste. There should be one window here as well. Let's see here. Okay, so this is how we basically do the windows. So what about the doors? Again, let's try with this one. Actually, we can try with this one. Let's see which. Actually, we can go with. It doesn't really matter, as long as you know which wall to choose. But in this case, I'm going for this side here. Then implement one door here. Let's see what we have opening. And the height of the door should be 2 meters, which is correct here. And the width 0.8. Let's see how it looks. Close this one down. And this, you can see a yellow bar here is actually the door. So let's try pull it down here. Let's put it down a little bit more. Okay, so you see you got our door here. And you can copy this one and paste it, for example, in all the places that there should be a door. Paste here, here, actually not here, but here. We have, should be one here actually also, for example. See here if I can target, copy, and paste. Remember, when you do the doors, you need to only create a door on one side of the zone. For example, we have this zone and we have this zone. You do not need to create door on each side. For example, here and here, you just need to create it on one of the zones, and then it will know that, okay, there should be a door. I will create an opening for it on this side. For example, here I create one door that goes into this room, and that's it. I do not need to create on this side as well. That's for the internal doors. For the external, let's click on paste, and you can see this door is actually too small, so I need to edit. Actually, I need to go into the room and edit it like this. And it should be 1.2 meters here. And we need to center it a bit, and I can configure it from the drawing. See here. Okay, this, you see, this is very good. Another thing you need to think about is to create schedules. Let's see here. Just wall to study room. I got some error here. It's this one. Some kind of error here. Okay, I'll check it. Let's see here, where was that? Yeah, the door. So if we click on this door, we need to set also the opening schedule. So for external doors, I would recommend, see here. I would actually recommend never open, because it's not very often you go in and out of the building just maybe a few minutes, 5-10 minutes per day maximum. Maybe not even that when these external doors are open. So for those, it should be never open. But for the interior ones, edit. Actually, not. I can double click instead. So this one should be. You can have it always open for the interior ones. And also, of course, for the windows, generally it should be never open. So you should not open the windows. So don't forget this part as well. I mean, for the adding the doors and the windows to the drawing. And okay, here we can see actually the door and some of the windows. So you need to actually finish these parts as well before you do the simulation. Let's do a test simulation here. See what happens. Okay, it is actually working. Let's clear this one out and do. I'm not going to do any simulation, but I'm just going to use this data to show you how to extract the things that we want. Again, this is not the correct data. It's important to keep that in mind because I did not add any windows. So you will get a different set of data. And then we have, let's see, I showed you the heating demand, performance simulation, how to find out how much the heating demand during 1 year. This is where you can find it. The heating for the entire system. And then which room has the highest? It was max heat supply to watt per square meter. Which part of building has the highest energy loss, which I already showed you in the multi-zone. That was this part. Now I have not done, actually I maybe should have, when I do a quick simulation here so I can show you. Just take 2 weeks. This shouldn't take a very long time, but the things I need is data so I can show you how to extract. Okay, nice. So what do I need to show? Which part of building has the highest energy loss? Yes, I showed you that previously. All zones, multi-zone, all zones, and then of course you only have 1 month now. Not even that. I only have 2 weeks. So it should be, in this case, it is envelope and thermal bridges, and the walls has the highest. And then we have, I should save a copy as I did before actually. So this is the base model. And then perform energy analysis. An example, change indoor air, thermal bridges, insulation, so on. So what you do is you have to have the answer to these questions you already have extracted. So you might ask, how do I extract this? I would like you to extract the tables with the help of the there is a Windows clipper. So this is pretty much this software. So take a new, let's see here, new, and then I can just cut this information, for example, and then save it into Word. Or when I needed the other information, this table, for example, I need, so I can just cut it and then I paste it into Word or something. So this is how you extract this information. This is what I want, because so I know that you have simulated, and I want to see some other figures as well. Okay. And then let's see here what we have. The next thing is perform an energy analysis. This will do, we can do by, for example, okay, so now that we have the base model, actually, it's a good idea to save this again, because this will be our base model. So we need to save this one again as, gonna save it as energy analysis. Save, okay. So for example, if I change, let's see, if I do a change in indoor temperature, or let's say thermal bridges. So go to thermal bridges and I change it to good, for example. Something like that. And then I make a new simulation. In your case, you have to do, of course, 1 year, but just for demonstration purpose, I will do it just for 2 weeks. And then, because we want to compare what happens if we change parameters in the simulation. For example, how much energy do I save if I lower the temperature by 1 degree, or I fix my thermal bridges, and so on. And as you can see here, we can actually go to, let's see here if I can find this one. Compare result. Energy analysis. Let's see if I can add cases. So base model. So you need to click add, click the base model, and then we have the energy analysis. And click OK here. So here we get a report that shows actually the two simulations side by side. Now, of course, you might not see actually everything in this comparison. So, for example, depending on what you change, you might have to actually extract them from each simulation by themselves, like going to the menus and so on. But you have a compare result button here as well. Okay, again, number 5, change some of these values. You can choose what you want to change and then compare to the base model and make a presentation. Okay, what happened? Did I save energy? Did I increase the energy usage? What happened? So you have to answer that question. The next one is try and reduce energy usage of the house by choosing your own retrofitting. This can be changing windows, increasing the insulation, installing ventilation system with heat recovery, and so Okay, and the aim is for a minimum of 25% reduction in energy usage. And you can also do a combination, which means that you can change several components, like installing an FTX system, and for example, change the air handling unit with heat recovery. You can increase insulation and so on. So you can reach this 25% reduction. For example, how do I change? You probably should already know how to change windows, how to increase the insulation, and so on. So how do I change the ventilation? You go back to General tab, air handling unit, replace air handling unit, and then standard air handling unit. Click OK here. So if you click on this, you see now we actually have heat recovery as well. So you do not need to change the settings really on this one if you're going to implement that. But remember to fix your supply air side when you do that. Because now you have actually a supply air side. And also remember to set the supply air should be, actually it's the return air should be around 10% higher than the supply air side. So around 0.32, oh wait, yeah, something like that, 0.32 in supply air you should have on all of these. So don't forget, except of course the Garrett, in case you are implementing an air handling unit. Yes, and compare the building versus the base model to evaluate the difference. And what I mean with that is you can evaluate it on the system level. So you can check the your total energy saving, and you also can actually check on a component level, which you do it here, and you can say, okay, where did I save? On which part here did I save mostly? So you can do that as well. Cost analysis. So this is not going to be extremely strict. Basically, the changes that you made over here, I would advise that you think about it in terms of economic perspective, because some of these changes might cost a lot of money. So many companies or house owners are not willing to pay a lot of money to decrease their energy usage. It's just not worth it. So when you are here, it's a good idea to actually think about roughly how much your retrofitting is going to cost. And in part 7 again, you can try and go to internet and search in Google, try and find roughly how much this change that you proposed will cost. Again, you don't need to like contact companies and get some estimations. I mean, you can do it if you want, but you're not forced to do it. You should be able to find some places that shows roughly what it costs. to do the retrofitting that you want. Number 8, when you have done your retrofit, examine the thermal comfort with the help of Fanger's comfort index. Okay. So let's go into multi-zone. Can check zone name. Okay. Actually, I think for this one, we should go to detail. We can go directly to detail. And here we have for each room. So I would recommend that you pick out, for example, the 4 main areas. Probably master room, master bedroom, kitchen, the family room. Let's see here, we have it. And the family room. Actually, 3 is enough. So family room, kitchen, and the main bedroom. Here you can check the Fanger's comfort indices, and you can check your comfort levels here. And we also have thermal comfort, as you can see, at what level you are. Here is with cooling, and here is without cooling. Okay, so this looks actually pretty good for this small simulation I made. Anyway, so what you need to do is you need to present this and have it in the report for these 3 bedrooms that I talked about. And then finally, present your work in IMRAD, introduction, method, result, and discussion. A written report and send it via Blackboard. You can work in groups of 2 if this is a campus course, and no groups for a web-based course. So depending on if you're a student here at the campus, then you're allowed to work in groups of 2. But if you are a student that are reading this course in a web-based format, then you're not allowed to be in groups, so you will submit it singularly. So keep that in mind. And if you have any questions or you get stuck somewhere, you're welcome to email me. I will also put my email in this document. I have not done it yet, but I will do that. So, and I will also write on Blackboard where you should submit this work. That's it, and I hope you will finish this work with excellence. Thanks and goodbye.